presentation is my personal opinion. Not NASA's, UARC, I work for, not Dayton, who's sitting right here, but I'm one of the microphones, it doesn't matter. I'm a user experience generalist is what I call myself because I do designing, testing, requirements, system engineering, project managing, all kinds of stuff. Mostly I'm a designer, but my PhD is in cognitive psychology, computer interaction, decision theory, research methodology. I threw most of that away back when I went to Bellcore in industry after a year, and Michael Muller there convinced me participatory methods are probably the best thing to do. Gave a talk at the Chi conference once with my friend John Carrot, where we told everybody in the audience pretty much your formal educational backgrounds are useless. And they were really pissed. Despite the fact we said we have the same educational backgrounds, and yes, they're pretty much useless too. I was at IBM's Watson Research Center as a postdoc, Bellcore, which became Telcordia, and that was pretty much dead. That was the research development branch of the phone companies. The other half of AT&T Bell Lab went with the regional phone companies. And then Sun Microsystems, and then joined NASA in 2004 to work on the MCT software I'll tell you about briefly. And this is Jonathan Knoll, stand up. This is Jonathan Knoll I work with. He's my partner at NASA Ames, and that's Jay Trimble, who's a principal investigator for the MCT project. Okay, I'm going to go kind of fast. Most people here are user experience type people, right? Yeah. Okay. So I thought I'd give you some background on the kinds of things you would need to know if you were to design for space stuff, which includes who are the users, what are their situations of use, what are their tasks. And then I'll tell you a little bit about participatory design methods that we use and a little bit about this object-oriented software called MCT. I'm going to start, well, first of all, this is just my personal experience, okay, so that's number one. Number two, so it's limited to a few places. Number two, I'm going to generalize some, so please don't say, well, it's not all like that. Yeah, I know, okay? So if it was a 3-hour talk, or I could tell you all about that. You can talk to me afterwards if you want more detail. So first of all, let's talk about Johnson Space Center. Johnson Space Center is in Houston, Texas. They do the crewed missions, things with people on them. They do the International Space Station. They do the Space Shuttle. They're going to do the new Orion space capsule vehicle that is going to go to asteroids or wherever. All those actually work a little bit differently from each other, and the users I'm going to be talking about are the people on the ground in mission control, in operations, who are monitoring and controlling all of those vehicles. The International Space Station is controlled largely from the ground. The astronauts, the crew on the space station run some of the payloads, some of the experiments. Some of the payloads are run remotely from the ground. But they don't actually run the space station's navigation and stuff day to day. That's done from the ground. In contrast, the space shuttle used to be run mostly by the crew, not by the ground. Another difference is the space station just goes round and round and round and round. It's kind of boring. The good thing about boring is that you get a lot of experience running it on the ground. You pretty much know what's going to happen. Now, when they were still building the thing, it's a little different because you go bolt something onto it, it doesn't behave the way it used to, but it's all built now. They get some new payloads up. They're relatively small payloads, so it's pretty predictable. They have a lot of experience. That means they can train people very thoroughly to run the thing. In contrast, the space shuttle went up and down. So when it's going up, it's rather terrifying. When it's coming down, it's rather terrifying. And the way you operate that thing from the ground in those two cases, mostly for those particular situations, is different than the way you run the thing when it's orbiting. So the running situations with the space shuttle you never run into with the space station. Well, you hope the space station starts to come down. You don't really have any procedures to deal with that. The Orion multi-purpose vehicle is going to be different still. It's going to be run mostly automatically on the vehicle itself. And the reason is, the intent of that is not to just go around and around the Earth. It's got to go far away. Moon, Mars, asteroids, whatever. It's going to be so far away that you cannot, from the ground, figure out what's going on and control it in real time. And you really don't want to burden the crew with trying to make the damn thing work constantly. They've got enough to do. So they're trying to make the thing be pretty much automatic. So that's Johnson Space Center. Here are physical spaces there. This is I don't know if this is station. Yeah, that's the International Space Station flight control room with all the thicker, or just the front room, if you And then behind the scenes, there are a bunch of other rooms, the back rooms, that do not look like that. They're big rooms. They do have consoles like that, but they don't generally have the big screens and all. The back rooms are called MIPSers, multi-purpose support rooms. And then there's an engineering room. There's one. I don't know if that's for station or shuttle. And that's me. And then they've got their personal offices as well. So those are all the spaces where these users of the ground software work. And they work in all of those things, and they communicate among those things too. So this will give you an idea of the diversity of the work situations. The front room has one or two people on each console here. So for a particular job, which is called a discipline, you have one or two people, usually one person, but if it's during a shift change or something really important is going on, they may have two people. But in the back room, you've got another console that the same discipline has people on, and they're all talking to each other from voice loops. And each one of these guys is actually listening to maybe 10 different voice loops, and one of them is louder than the other ones. So back to the situation of use. So here's some person on this console. They are watching all these screens. They are not usually watching the ones up there, but they are on the voice loops with everybody in this room, plus their own backroom people, and a bunch of other backroom people. And they've got a telephone, and they've got email, and they will stand up occasionally and go over here. They got really long cords on their headsets, and they talk to people in person. All that is going on, and then this little console right here you can barely see is how they choose which of these, I don't know, 30 or 40 of these voice channels that are available to decide which one to make loudest. So they're listening to like 10 of them, and one of them is louder. And all this other stuff is going on at the same time. It is very complicated. There is a lot of collaboration. Some disciplines don't have front rooms, they just have a back room. You always have somebody in the back room. At night, when the crew's asleep, then you don't need that many people. Sometimes there's nobody in the front room either. It depends on the discipline. I'm trying to get across that it's a very complex situation in terms of who are the users, what are they doing, and what are their situations of use. The person in the front room's role compared to the people in the back room. The person in the front room stands the power person. In the front room on the console, they are responsible for being the representative to the flight director and the rest of the people in the front room for that discipline. That doesn't mean that they're in charge of their discipline exactly. It goes back and forth. They are responsible for monitoring what's going on, which means they don't have the mental capacity or the time to do a lot of investigation if something is odd. They see something odd, they're talking to their backroom people on the voice loop. People in the backroom have got the time to do the research. But it's not just the front room person telling the back people, here, I'm going to task you with doing investigation. Sometimes that happens. Sometimes it's the backroom people who are telling the person in the front room, here's what's going on, here's what we recommend that you say, here's what we need you to say. The person in the front room is the one who gets to make the decision about what to say to the flight director, but the roles, the power are not all straightforward. It's really a very close-knit team. So again, this is a very complicated situation. This is not like a submarine where you've got the commander and got everybody else who does exactly what the commander says. The person's a good commander, they listen to everybody. This is a much more interesting interaction experience. One more interesting thing, the only person who's supposed to talk to the crew is the CAPCOM, capsule communicators. It's next to the flight director. Nobody else talks to the crew, and that's to avoid confusion, conflicts, etc. Most of the time. Jay's looking at the commanding of the vehicle is done by only a few of these disciplines. Not everybody can send commands. Again, commands are dangerous. Monitoring safe, commanding dangerous. Monitoring can be dangerous if you make the wrong decision about what to command. But again, that adds to the complexity of all the workflows. How many disciplines? Oh, geez. Jay, the station, I told you you couldn't talk. In the front room, I think for station, they've got like 15 people sitting in there. A dozen disciplines, 2 dozen disciplines. Please. 10 or 12 disciplines. Yeah. So not a huge number. The total number of people is higher than that. They've got maybe 10 people per discipline, 3 per discipline, because they've got shifts, right? You've got 24 hours a shift, 24 hours a day. You have to have people there in case somebody's sick, goes on holiday. The way that Johnson Space Center tends to work is to do planning, what you're going to do, train, and I boldface that because at JSC training is extremely important, and then doing the flying, which is monitoring, sending commands, etc. For a space station, generally they have a lot of time to respond to situations because it goes round and round. It's a nice stable vehicle, they're not building it anymore, except for some particular cases, and they're always ready to safe the vehicle. That's the number one thing they're trying to do. Other than that, they've got often some hours or even days to figure out what to do. That's very different from the shuttle. If the shuttle, and Orion for that matter, are ascending, the people, the disciplines that are responsible for monitoring that have to respond instantly. So the way they do their job, and in fact their attitude and their tools, are very different than the ones for people who've got usually a lot more time to respond to something. So you can't just go in and design for a flight controller. You have to know what their vehicle is, you have to know what their discipline is, you have to know what phase of the flight they're in, that they're dealing with right now. Sometimes it's terrifying, sometimes it's relaxed. This is interesting. The command sequences for station tend to be broken up into relatively short sets compared to some other vehicles, and that's because the station is close enough to the ground that you can get feedback pretty quickly. So you can figure out what to command, send a command, see what happens, see the feedback, see what the instruments say, then send another command. You've also got a crew up there who can watch stuff for you. So it's almost real time, not quite. However, the time lag is long enough, even for station, because it's not just light speed, it's got to come down through the antennas, get through the ground processing systems, etc., that you have to rely on the crew and the equipment on the station to respond immediately to emergencies. So if there's a fire, the crew's going to smell the fire and do the appropriate thing to put it out before the people on the ground even really realize that there's a fire. So they're not relying on the folks on the ground for instantaneous response for really, really critical stuff, for the most part. Skip that. What have we got here? So if you're watching the video later, you can go back and see it. JPL is different. Again, I'm generalizing. JPL sends things that are not crewed, do not have people on them. Communication very often is delayed a lot because it's on Mars. You've got an average lifetime of 20 minutes for radio signals to go. That's each way. So you've got a problem here. Also, the vehicles, if they're really far away, like on the surface of Mars, cannot communicate anytime you want to the Earth. They don't have the Earth in view. If they have the Earth in view, the antennas on the vehicles are usually not powerful enough to send much data to Earth directly. So instead, they use orbiters around Mars. Oh, but they can't see the orbiters. The orbiters pass over just occasionally. It's very complicated. There are only certain windows where you can do anything. As an example, for the Mars exploration rovers, the controllers, the flight controllers, would, in the morning, well, Martian morning, send up commands to the vehicle, to the rover, telling it what to do, and would get data back, and then, send commands to the rover, have it do its thing for a few hours during the Martian day. Then the rover sends back the data, and the people on the ground then, I would say frantically, except they're not frantic, they're just very busy, will calmly, but with great purpose, spend the next several hours figuring out what the hell happened, looking at the data. Maybe it just sat there doing nothing all day long. You know, maybe there was something wrong. Maybe it found something. Maybe it ran into a rock. Maybe it's in a ditch. We don't know. It saw something interesting that changes what we want to do. Figure out what they want it to do the next day. Construct the commands. Do this laborious, time-intensive checking of the command sequences to make sure that the commands are correct. Send the commands up there so that the next morning the rover can go do its thing again. So and if you send the wrong commands, it might just sit there doing nothing until it sends back data saying, I'm here, okay. That's very different from space station, space shuttle. They're so close that you can get near real-time feedback. So now, geez, we can't just design for space. We can't just design for space missions assuming there's a near real-time situation. You really have to know exactly the situation with the vehicle, where it is, what your communication opportunities are. You also have very poor awareness of, you the case of a rover, the situation it's in. Really, I had too many slides. The rovers, when they're on Mars, for example, you really are not very sure about the terrain they're in, so you can't just tell it, oh, go 20 meters. Right? As opposed to something that's in space, it's just going around and around, or it's going through space, you're pretty sure there isn't a flock of geese in the way, so you can just squirt some jet juice out and it'll go in that direction, and you know physics. Okay? Rovers, much, much harder. Okay, there's JPL's darkroom you see on TV when they do missions. They only use that for things that are high press events. The rest of the time, they're much more boring ones. It's called the darkroom. Ames Research Center also has an mission operations center. It's much smaller, but it can be used to run like JSC stuff, like JPL stuff. We also do CubeSats at NASA. Ames. Here's a Cube satellite, and yes, this is the real hardware. This one's not going to fly, but it's the real hardware. This is how big it is. It's got solar panels. This one is a phone sat. It's got a telephone inside. That's how they run the thing. Because hey, they're cheap, and if they're radiation resistant enough to last as long as you need it to, which is not very long for tiny things, they tend to deorbit really quick. Why not? There was a phone sat mission successfully that flew several of these. You can go to phonesat.org and read all about it. They deorbited in April, and here's an example of them ham radio operator stations, which is how they got their data, because they couldn't afford the deep space network. We have a few NASA fact sheets for PhoneSat if you want those too. Participatory analysis, design, and assessment. So that was my background on that. Now, how we do designing, where I live, Madeline, is we tend to use really low-tech stuff. Round tables, post-it notes, index cards. This is flat on the table, not on the wall. We don't use real tape until we're really, really, really done. This is from a project they actually carefully folded this up with post-it tape, just like post-it notes, except with tape, and took it on an airplane to the Jet Propulsion Lab to check it out with some customers, carefully brought it back. This is very carefully color-coded, believe it or not, and this helped get a project's act together. Participatory design has users really collaborate, really, 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 and truly. We use paper prototypes on this stuff. So after you've done a task that goes like that, this is an actual paper prototype of Mission Control Technologies plotting interface done by actual users and us at a table together. 87 over the course of a couple days, and then it turns into a nicer kind of a spec, usually, but oftentimes it just lives as pictures of those things because you don't have much time. If you want to know more about participatory design, you can read about one of these methods that we use here. There's a book chapter, and there's a short videos here about what we do. I'll leave that up, so if you're watching the video, you can see it. And we've done this even semi-remotely. Our Johnson Space Center users are in Houston. We've done we did this for years with them. We had initial meetings with them, us there, where we did these sessions. They would come to us occasionally every few months. And in the meantime, we were on the phone, instant message, email, any time that they wanted to call anybody on our team, including our developers, they could. Any of our developers, anyone on the team could call them. We all hung out in the same lab here, so we could always overhear when that was going on. There was a lot of communication inside the team. So you can't escape doing participatory design just because your users don't live where you live. Object-oriented style GUIs. This is something that we use for mission control technologies. It's a style user interface that includes having the users think of the data objects they care about rather than the applications. It provides a lot of flexibility so users can compose things, which is nice because given all the background I told you about the variety of users, situations of use, and tasks, it is really hard to do a straight-like application for every one of those combinations. So instead, we use this style of user interface which lets users kind of compose their own things as they go along. I'm not going to try to explain all that. There is an explanation here on our blog of how object-oriented GUIs are like science fiction user interfaces you see. And there's a short video about our MCT software that And there's the MCT website. And by the way, our MCT software is open source. We would really, really like you guys to download MCT. The demo is a very, very simple one-file download, and you can run it. We have a 3-minute video on the website showing you how to use this. You can try to use it following along with the video. And the code is on GitHub, and we want people to build plugins. It's not just about space stuff. It's a general purpose object-oriented GUI thing. NASA paid for it, so the plugins right now are mostly about NASA stuff. But please go there, and if you can't read that, just search the internet for NASA open MCT. You can find it. That there, so on the video you can find it, read it. And there's an example of MCT displays. I'm going to skip because I don't have time. Right. If you want to work at NASA Ames through UARC, which is the gentleman I work for, it's the University of California, Santa Cruz. We're contracted through UC Santa Cruz to NASA. There's how you can find out about internships and about real jobs. Not that an internship's not a real job. Slave labor. Okay. We're done.
All right, thank you very much. We have time for a question. We'll set up for the next one if anybody has a question.
Questions? Yes.
Yeah, so you're saying that we had a conversation going on, five screens around and stuff like that. How does that sort of very attentionally demanding environment impact the UX? What can users not do in that sort of sense to make it better?
I can bring it back. Sorry. My fault.
Well, one thing is what's called quiet dark. In aircraft, submarines and such, notion very often is to make everything quiet unless something goes wrong, and then make it make a sound. Make everything dark unless something goes wrong, make it bright. So they like generally dark backgrounds on their screens. They do have audio alerts, but they're minimal. They get to control what those audio alerts are. Actually, they're disciplined for a job because sometimes what pressure goes above a certain level, most of those things don't care. It's only people who specialize in that who care about that. Another thing that the busyness, they've got a ton of stuff there, but they tend to leave it alone. They use pattern recognition a lot. So yes, they're horribly complex screens, and they're teeny tiny. And these are 6-foot wide consoles generally, and so you'll see them sitting down here and looking over there. And you're thinking, there is no way they can read that. And generally, no, they can't. But what they can do is because they keep everything in the same place, they've trained for so long, this is JSC, they'll notice a twitch. Color changes, value changes. Maybe that number is always the same. They also try to do the way they set up their parameter, the telemetry parameters. You really want the numbers to never change for most things. So that means you don't have a screen full of these numbers flipping around. It's just all stable, which seems really boring, except twitch and move my chair, look at this, talk on your loop. And these are voice loops. You don't have to necessarily press buttons and stuff to talk on voice loop if you don't want. So they can say, hey guys, my own background.